Hello, my fellow explorers of the neural cosmos. Ernis here, ready to guide you through an astonishing paper from the bleeding edge of AI. We're going to dissect Kimi Linear, an expressive, efficient attention architecture. Sounds intimidating, right? Don't worry, I'll translate the technobabble into something even your pet rock could understand. Now, before we dive in, picture this. A bustling city powered by 1,000,000 tiny robots, each responsible for delivering information. That's kind of like how attention works in large language models. But what if those robots could talk to each other directly, sharing information without bothering central command? That's the breakthrough Kimi Linear is bringing to the table. So, what's the paper's core argument? Simply put, Kimi Linear introduces a new kind of attention mechanism that is both faster and more accurate than existing methods, especially when dealing with long sequences of text. They call it Kimi Delta Attention, or KDA. It's like giving those robots jetpacks and telepathy. Now, how do they do it? Let's construct our memory palace to explore this. Imagine a grand library, each room representing a key aspect of Kimi Linear. First, we enter the gating room. This is where the magic happens. See, existing linear attention methods often struggle with long contexts because they forget important information. Kimi Linear introduces a finer, grained gating mechanism like tiny valves controlling the flow of information. It's like giving each robot a personalized memory filter so they only remember what's relevant. Next, we stroll into the chunking chamber. To speed things up, the authors use a clever, chunkwise algorithm. Think of it as dividing the city into smaller, more manageable districts. This allows the robots to work in parallel, processing information much faster. Fine, yeah, I guess. But the cool thing is that they use a special kind of matrix, a diagonal plus low rank matrix, or DPLR, that makes the math super efficient. Now, hold on, this is where it gets really interesting. Imagine you're a data packet traveling through the network of an AI. And you need to decide which parts of the past are important. But the network is vast, and remembering everything is impossible. Kimi Delta Attention is like having a smart guide that knows exactly which paths to take, which memories to access, and which ones to ignore. It does this by dynamically adjusting the forgetfulness of each connection in the network. Now we move to the hybrid hall. Kimi Linear isn't just about KDA, it's a hybrid architecture. Meaning it combines KDA with traditional, full attention layers. Think of it as having both those super efficient robots and a few wise elders who can see the big picture. The authors found that a 3-to-1 ratio of KDA to full attention layers struck the perfect balance between speed and accuracy. So, what are the real-world applications? Well, the authors show that Kimi Linear can be a drop-in replacement for existing attention architectures, leading to significant improvements in performance and efficiency. This could revolutionize tasks like long-form text generation. Imagine AI that can write entire novels or screenplays without losing track of the plot. Reinforcement learning. Think of robots that can learn complex tasks much faster and more efficiently. Real-time language translation. Envision seamless communication across languages, without any lag or delay. You might be wondering, is this just another research paper with no practical impact? Au contraire? The authors have open-sourced their KDA kernel and released pre-trained models. That means anyone can start experimenting with Kimi Linear right now. And the results speak for themselves. In their experiments, Kimi Linear outperformed existing methods on a variety of tasks, while reducing memory usage by up to 75% and achieving up to 6x faster decoding. 6 times faster. That's like going from a horse-drawn carriage to a warp-speed starship. So, what's the takeaway? Kimi Linear represents a significant step forward in attention architectures. It's faster, more efficient, and more accurate than existing methods, making it a promising solution for a wide range of AI applications. We are at the edge of something remarkable here, a future where AI can understand and process information with unprecedented speed and efficiency. This, my friends, is not just about algorithms, it's about unlocking new possibilities for human-computer collaboration. The paper shows that Kimi Linear consistently matches or outperforms strong full attention baselines across short context, long context, and RL style post-training tasks while achieving up to 6x higher decoding throughput at 1M context length. So, go forth and explore the cosmos of Kimi Linear. Download the code, read the paper, and start building the future. And remember, the only limit is your imagination. Until next time, keep exploring.